Good morning. We are back again. So far, I have been concentrating on simple sheet metal work with which you will be able to make small equipment that is required in things related to instrumentation and such places. Now we are in the Power Electronics lab of DESC, Indian Institute of Science, Bangalore. So you see here two types of activities are there. One of them is basically our students try to learn techniques in control, and while control is good, and we need to learn basic working with the basic power electronics is a field by itself. Unlike other fields, we have a little problem here because of the heavy investments needed and all that. Power electronics companies have invested heavily into both improvement of the semiconductors, classically the IGBTs, and then also improvement in the boxes or the packaging issues related with it. This is depending on the application. It varies from highly harsh to relatively simpler items. Now we'll have a look at the one of the things which is regularly used in the labs. This is a very simple power device. You see here we have a heat, while it's not an infinite heat sink, conventionally it is called a heat sink. It is nothing but something which dissipates heat. And then this is a fully completed drive, tough. If you see the drive, the actual active element is probably only this much. Understood? The active element which does the switching element is only this little brownish colored module. Loosely let me call it an IGBT without further qualifying it. One of the first things you will notice is, while the IGBT technology has improved tremendously, the other associated things still need to be carried on. One of them is it needs tremendous gating circuits and so on, and we still have the issue of a monstrous capacitor for stabilizing the DC link voltages. And then all of them are generally made to for around, the researcher tells me it's all around 600 volts. While the input of it is a DC link, and the output you have the usual RYB going to various other things. Most critical part of it is cooling. Whether you like it or not, in spite of all of them being switched devices, there is still tremendous generation of heat. In spite of them being switched devices, there is a tremendous amount of heat. Now, if you go back to the device, you see here we have two nipples here, brass nipples. These brass nipples are connected to an elaborate water cooling circuit underneath this. Underneath this we have a water cooling circuit. So we have a cold plate, and then depending on the type of input we give, we can control the temperature. Traditionally they try to use only normal ambient temperature water cooled devices. Afterwards I'll show you this. If you give it is obvious, if you give any fluid at a given temperature, this will come out a little hotter depending on the rate of temperature rise. You would have also seen it in what is called your 1 liter instant geyser. The traditional 1 liter instant geyser, if you keep it in a bucket of water, it will give you around 5 to 10 degrees rise in temperature. At very low flow, it will give you 10 degrees. When it is flowing freely, it will add to about 2 degrees to 3 degrees centigrade. I will now point out to you the way anybody will start their design. So at the back of me, you see that we have several of these power devices, and then most of these power devices invariably they get mounted on a heat sink of sorts. Then these are all the gating circuits. You may ask me, is it real or is it there? Yes, all of it is real, all of it has been tried, and that's why I say I am not touching them. I do not know if they are actually really live. And then we have this heat spreader on which invariably all these gating devices are mounted. This cover has been taken from that unit. It is intentional, just to show you that what looks smooth outside. And in fact, it looks a little like what you are likely to find in an automobile engine. So you have a nice cover outside, and then you have this what are traditionally called counter bore, but open counter bore. They can put a screw and tighten it. Intentionally, it has been made smooth and so that it does not attract dust. But you see inside, a little bit of design which is quite a little like your plastic design is still there. You have ribbing here, overall thickness is kept to the minimum, and you have a gasket here. And you see the formation of the gasket, it follows inside those things. The starting point of the drive, what you have seen there, is probably very crude aluminum casting. Right now, because it's our purpose is to learn, they've adopted one of the standard practices. This is a normal green mold or gravity die casting, sand die casting, not made in a thing. You see here, things look a little rough, and you may even find what are called mold flashes. You find flashes here, and the most important point is that we are trying to reproduce what all that cooling circuit is there inside. A word of caution here, you should never open an existing equipment and try to copy. You should never open an existing equipment and try to copy whatever they have done there. First issue is material is different. Secondly, the cooling techniques are different, the liquid and all that. Thirdly, transient behavior is very different because of the material properties. When you do the thing, it may work, and in fact, it may even stand for a soak test, a 24-hour soak test under simulated bad conditions. It may still hold. However, in a matter of time, maybe a few months, you'll see that things start deteriorating, and the first leakage, everything explodes. So I'll now point out to the power devices. So typically, this is that brown colored device you have seen here. This is what you are likely to find inside. This is all these power devices. You've seen this. Something happened and everything has blown up. Not easy. We have this here. This thing sit here, and this it is all transferred to another clamping plate. That clamping plate comes and sits here. So right now, what our people will try to do is apply a tremendous factor of safety. Part of the factor of safety is, after drilling all this and then making some channels, they will see if this aluminum itself is sufficient, and as much as possible not copy the device which is there. The device which I have shown you is a problem. And now have a look at even these monstrous, I don't know what I'd call them. They're actually DC link connectors. Now you know how important it is to take this amount of current. You see here, they're thick, and outside, while it looks like that, I'm not sure actually whether it's aluminum or it's copper. Several times they directly use copper, and then it is plated to make sure that is there, and then any voltage drop is not allowed. We have come to another section of the same power electronics lab. I thought I'll show you that all these things, when they start, it's very convenient for us to start with simple sheet metal. So we have a C-shaped support. Then we have this so-called heat spreader. Then the devices are all mounted there, and then it is easy for us to understand, analyze, and it's not tightly packed. So researchers start from here. Then the whole place, you see here, these are the capacitors and that link voltage what I was talking to you about, link current. So they try their best to put whatever they can do, and then see that the basic technology is proven. After the whole thing is proven, we probably end up with a product like this. This is about made 25-30 years old, made for a high speed induction motor that is used in a PCB drill. You see here it says 1000 RPM, 50. So it is expected to work beautifully at 50,000 RPM. That's a lot of RPM. And then it has all the features. Why I am showing it is a complete product like this. This is still a sheet metal part. You have the heat spreader here, and then it has been made specifically in this condition so that it can be done on a table. Otherwise, classically, these things will go into a rack. In the case of a rack, this whole thing will probably go up like this. And the control elements which were shown in the front may be mounted here, otherwise they are mounted on a extender. And sometimes it may be even reversed. You may not see that heat spreader and all. This is how it will be with all the necessary things. This part of it, which you see here, may go to the back of it. But for demonstration purposes, they have made it here. Coming back to another location where we don't have the side supports, devices here have been kept here directly. Luckily, when people work in such labs, the labs are built very carefully. The whole power may be via a completely isolated transformer. So to the extent, normally if you touch something, you will not get a horrible thing, what you call a horrible shock. And then sometimes even the floors are insulated. In this case, we have not yet insulated it. In future, we will insulate it. So you see here, we still continue to use that heat spreaders everywhere, and then so much of paraphernalia is required so that eventually we can drive a motor. And things like variable frequency, variable voltage is very common in the industry. It is not as reliable and as energy efficient as they claim. So still issues relating to the harmonics and whether we can have one inverter working at various operating two motors, such things are being done here still. Now we are in a what looks almost like a museum. It's not actually a museum, it's a store. We are being shifted to another location, hence this place. You see here the original Semicron have made these things available before people could work on the finished drive there. So we have a picture here which just shows the old drive. But for safety's sake, instead of keeping them open like that, they have put everything neatly on a covered by acrylic sheets, and then there you also see one huge blower in the right side. You see the inlet to the blower, and then there's a black colored thing. That one is the what they call a radial blower. Unlike the axial, it's a radial blower. It directly blows over this heat sink here, and we have full control about everything. Simple air cooled, and then the gate drive circuits are available here. And then this here, there are equipment you see here, though it's a very specialist equipment, it still continues to be made using our normal what you are likely to find in the workshop. The equipment what I have shown you is having an honored place Can you see? What you see there is the top usual thing, and the bottom, the resting place is India's attempt at the supercomputer. So this is on the base of the, I do not know whether it's part of the power supply or something. So you see, this whole thing has been assembled using very conventional 19-inch rack components. So you see here, this again is a heat spreader, and then you see, I just wanted to show you that this is the supercomputer. Thank you. What are the equipment racks which people use all the time? This is from the side view of it. You'll notice that the same operations as the perforations that are done in the front have been also copied here. Main attraction is that you can continue to mount the shelves in which you can mount the equipment. So typically this is a shelf, and then you have various equipment here, and then we have all the cable trays which take all the cables. And since it's just getting ready, most of it is not populated. Now we'll have a look at the front. So you see here, one more time, these are all the various switching devices, and these are all the connectors. Some of them are just reflected back to front, and then you have these cable packing things. And then what I was talking about, this U business, we have these numbers of U's there, so that when you start ordering the equipment, you can see how much it is. One U typically is 44.45 millimeters. So multiples of it is what all equipments are made from. We have gaps, we have everything, and then we have so many of these peripheral equipment. And finally, to make everything test proof, we have a cover. Okay. Once I cover it, it's not likely that you see anything. And then you can also see something which is very, very critical here. This is called the lab certification against fire. So in case there is a fire, it is unlikely that they will be extending the fire. This is certification against fire safety. So this will ensure that even if you keep them in a confined environment, nothing will happen.